Okay, let's go to the next presentation. Is Mr. Amitabha Mukhopadhyay from Kuwait, who is going to talk about numerical modeling of pumping test data at an artificial recharge site in Kuwait. 6 minutes, please.
Good afternoon, everybody. So, okay.
Gracias.
Okay. Thank you. Good afternoon, everybody. So today, what I am going to present is how we have used pumping test data to calibrate a numerical model which have been used for simulating artificial recharge at one of the sites in Kuwait. We have, there is a pilot-scale recharge recovery experiment which is taking place in Kuwait. The target aquifer is Dammam limestone formation. We carried out a pumping test in the soil for 96 hours, followed by 96 hours of rest period. And there are 6 monitoring wells. Before we started the actual recharge, we thought that we can use this water level data that we collected from this pumping test to calibrate the numerical model. And we used VMOD flow classic version for this area, for this simulation. The total area was 18 kilometer by 18 kilometer, and which was aligned parallel to the hydraulic gradient in the area. And the grid size varied from 0.6 to 5 meter near the injection wells to about 1,000 meter near the boundaries. And 5 layers were introduced in this model. 2 for the overlying sandy Kuwaiti group, and the 3 for the Dammam limestone formation itself. And several rounds of what happened that we thought that it should be very easy because we have the pumping test data. We have estimated the hydraulic conductivity from this pumping test. And if we just plug in these things in the model and make with little adjustment, we should get a very good model. But what happened when we tried that, we could get a good match in the injection, the ASR well. But for the monitoring wells, whatever we tried, we could not get a good match. And we struggled with it for more than 1 month. And then what happened that we thought that, okay, this formation about 40 to 50 kilometers southwest of that area where we are doing this test, is known to be very much castified with big fractures and caverns, and the hydraulic conductivity is very high there, in the range of about anywhere between 5 to 50 meter per day. Whereas in this site, it was only in the range of, from the pumping test, 0.2 to 0.4 meter per day. However, we thought that since there are fractures or castified areas in this formation in the 40 to 50 kilometer distance, it's quite possible that there are a few fractures or high conductivity zone in this area. So what we did, originally all this ASR well and 5 of the monitoring wells were aligned parallel to the hydraulic gradient. So we assumed a fracture zone along this line. And when we did that, we could get a much better match with what we observed in during the pumping test. And this is the part of the model grid. In the left-hand side, we are saying that no fracture zone, whereas on the right-hand side, we have assumed a fracture with conductivities are shown and from 18 to 100 meter per day. And when we did that, as you can see, of course, for the ASR well, for both cases, we could get a reasonable match. Whether there's a fracture or not, we could get a reasonable match. But for the monitoring well, this MW5, it is almost 50 meter from up gradient from the ASR well. We could not get a good match without this fracture, but when we assumed the fracture, the match was very good. And also, we made some, when we used the MT3DS to simulate the quality, we could find, this is the, after the, for the injection oil, we did also by now we have completed 3 cycles of injection and recovery. And this shows the head versus time and quality versus time in this oil. Of course, in the injection oil, during the injection, there was some problem of clogging because we did not realize earlier, but afterwards when we measured the suspended solids, there is about 2 milligram per liter of suspended solids in the injection water. So I think that was causing the clogging, and the water level in the oil was going up more than what we calculated from the model. But the quality that we calculated using MT3DS is very good match. And of course, as we said before, this MW5, the match was, sorry, I went, okay. And for the, for the MW5 also, with this assumption of the fracture, we got a very good match from the observed and head, and also observed quality. So the conclusion was that by using the pumping test data for the calibration of the model, we could resolve the actual hydrogeological setup of the area and could get a much better calibration run. And that calibrated model found to be quite effective in simulating the actual artificial recharge cycles that we have carried out up till now, 3 cycles. And I must acknowledge that this study has been partially funded by the Ministry of Electricity and Water of the government of Kuwait. And they have also given permission to present this paper here. And also I have got permission from my employer, Kuwait Institute for Scientific Research, who is conducting this study. And thank you very much.
You're welcome. Thank you so much. We have time for 1 or 2 questions. Okay. Thank you.